everyone will enjoy this session. Please keep yourself muted. Everyone, please keep yourself muted. I'll be going a little bit fast. So first we'll understand what is the electric force between two charges. Let's say there is this charge Q, okay, and let's say there's another charge Q naught. Now, actually, what happens is every charge is responsible for a certain field. It's a concept. Consider these charges to be like charges, two negative charges or two positive charges. For now, let's consider it to be two negative charges. And in this case, what happens is uh, when you bring this Q naught in the presence of Q, first of all, Q already has a certain amount of, it already has a certain amount of charge. Considering the fact that these two are positive charges for now, let's consider them to be positive charges. So, what will be the electric field lines? How will it be? How will it be actually drawn? Let's see. It will be in this format. So everyone is bear with me. Electric field lines on Q will be in this direction. Okay, will all be in this direction. And so what happens is when you bring Q naught in the presence of Q, okay, when you bring Q naught in the presence of Q, it is going to experience a certain force. And we know Coulomb's force, Coulomb's law, which says F is equal to A, okay, Q, in this case, this is the Q, and this will be a Q naught divided by R square. Okay. So this is Coulomb's law. It states that there is a force between these two, which is directly proportional to the charges and inversely proportional to the square of the distance between them, considering the fact that the the distance between this is R. So it's R square. Now, what is electric field, and why was this concept developed? Actually, when you look at this charge Q, okay, it is going to produce an electric field. This electric field will not reach Q naught if Q naught is very far. It will take some time, and it reaches at the speed of light. Okay, it does travel. It travels, but it travels at a speed of light. Okay, you can check it out on the internet, and you can see what actually happens is the charge has some capacity to produce electric field lines, okay, which is just a concept. And this electric field line takes time to travel. And so Q naught won't be immediately affected by Q. It will be affected after a certain interval of time t. Okay, let's consider that time to be t. So when you bring Q naught in the, now for example, you bring Q naught in the presence of Q, you already brought it will experience a force, and that force is termed as electric force, electric field intensity. Okay, in some books it is electric field intensity, some electric force, some electric field. Doesn't matter. What electric field intensity simply means is that electric field intensity E, okay, will be the force experienced by this charge Q naught. Okay, this charge is upon Q naught. Okay, who is experiencing the force? Q naught is experiencing. So force upon Q naught. Okay, so if we know what F is, okay, considering F is equal to, okay, E is equal to F, and F was what? K Q1 Q naught by R square, okay, and upon Q naught. So this Q naught gets cancelled. So your electric field intensity is basically KQ by R square. Okay, I hope you have understood this small fact. Okay, those who know, very good. Those who have moved ahead, it's very nice. I'm just explaining it so that everyone understands. You need to understand that electric field intensity at this point is independent of this charge. Okay, it is independent of this charge. Doesn't matter. Okay, this Q naught doesn't matter. What matters is the amount of force this is actually producing on this charge. And so electric field intensity is basically defined as K Q1 upon R square. Okay, where Q is this one. Okay, and K is simply 9 into 10 raised to 9 Newton meter raised to minus 2 into Coulomb raised to minus 2. Okay, you need to know all these small things. What are the dimensions? What are the units? SI units. You will go ahead with all that. Okay. Now you know that the electric field intensity on charge Q naught in the presence of Q is equal to E K Q by R square. Now let's see what will be the, let me look what the topic is actually taking about space. Let's see what is the electric field intensity on a charge Q with respect to a uniformly charged ring. Okay, pay attention, everyone. It's very simple, and those who know very good. Okay. Let's consider this to be a ring. Okay, please bear with me. The board is actually very small, and so what happens is it is zoomed in, so I have very less amount of space. So I'll be continuously erasing the equations. So if you have to write down, please write down with me, and it will be helpful. Okay, let's consider this to be a uniformly charged ring. Please mind my drawings. And let's consider there's a point over here, P. Okay, let's consider this to be having a point P over here. And P is at a certain distance from the ring, considering this as R. Okay, this is R. So, also let's consider this to be having some radius, capital R. Okay. Consider this to be having a radius, capital R. Mind my handwriting, it's not very good. Okay. So, I want to tell you a small trick. When you're doing um, a sum where you're finding the electric field intensity due to a ring, it's always good to take a small element. And why, I will tell you. Why can't we do it without derivation and integration? The thing is, if you take a small element dq, let's consider this. There's a small element over here, okay, and it is dq. dq. This dq is the same thing which we did earlier. That is the point charge, the force of 2 point charge, the electric field intensity into charges. This small amount of dq is going to produce some amount of force. Okay, some amount of force on this point P. Now, for example, take this P as a point where you have brought a test charge. Doesn't matter because anyways, the electric field intensity is independent of the test charge. Okay, so there is this dq. Okay, it is going to produce a certain amount of force on this point, considering that to be a test charge in this angle, in this along this one, and this will be dE. Why is it dE? Because you are taking dq. Okay, if you are taking a small amount of charge and you're finding out the electric field intensity due to the small amount of charge, it would be a small amount of electric field intensity also. I hope you're understanding this. It's very simple. Okay. Now we know Pythagoras theorem. This you know the distance between these 2 points is basically what? It is root of capital R square plus small r square. Okay. This capital R and the small r. Okay. So that is r square plus r square. I hope you know that. Okay. Now let's go to the equation part. Okay. Once you get this small drawing, you should be able to draw these small things, and then you can directly jump into the equation without actually worrying about how complicated it is going to be. It's going to be very easy. Trust me. So you take, that E is equal to. Okay, write it down with me if you don't know about it. If you know about it, good. It's kind of a revision. So KQ, okay, by R square. And so what this is the general form. Now let's look if you're considering dq and de, it will be differentiation of this electric field intensity, which will be equal to dq in this field. dq. Why? Because k is constant and r is constant. Anyways, you're going to differentiate the variables. Okay. So de is equal to k into dq upon r square. But what is r? What is r square? Okay. What is this r square? R square is simply the distance between these two charges, which you get by Pythagoras theorem, that is k, dq upon, okay, r square. R square mein, if you put this, you will simply get r square plus small r square. Okay. I hope this is very understandable. Okay. So now this is dE. It is dE, but it is the electric field intensity at a certain angle from the x-axis. What we want is the electric field intensity at the axis of this ring. Okay, we want electric field intensity at this point. Okay, we want. So this is dE cos theta. Okay, why? This is making an angle theta, and the same thing here will be an angle theta. Some are asking why. If you take a straight line, you bisect it like this, and the angle over here will be equal to the angle over here. Okay, so these two angles are basically equal. That is a nice standard subject. Nothing to be ashamed of. If you don't know, you just need to work hard. Okay, so D. So now since I said we found DE over here at this point, we need to find at DE cos theta. This is DE. You take it at a certain angle. It's DE cos theta. So you just multiply cos theta on both sides. So what will you get? You get, just dropping it off. You can write it all along with me. So you get DE cos theta equal to K dq upon r square. Okay. Sorry. Wait. This r is basically capital R square plus r square into cos theta. Okay. Now look at this. Here, this theta, okay, cos theta, can be written in some other form. So what is cos theta? We have studied it in 10th, adjacent upon hypotenuse. So what is adjacent? Small r.
Small
What is
r.
hypotenuse? This is the
Under root r
hypotenuse.
square.
So we will write that. So cos theta can be written as adjacent upon hypotenuse. Adjacent is small r, hypotenuse is root of r square plus r square. I hope this is understandable. It's a simple thing. Okay. Simplifying this, r square plus r square, raise this entire thing into this will give you a simplified amount of equations. You get, okay, what will you get? You get r square plus r square, small r square. And see, this r is the radius of this ring. The small r is the distance between these two. Okay, get raised to 3 by 2. Okay, 1 plus 1 by 2 is 3 by 2. Raised to 3 by 2. Okay, so now you have written cos theta in terms of r and capital R. Okay, now what you need to do is you need to integrate. Why integrate? Because right now everything in this equation, the constant k, this k is constant, r is constant, small r is constant, this r is constant. What is not constant is dq. What is dq? It's a small amount of charge at this ring. We have taken a small element, so we need to integrate that. Okay, I'm going to rub it off. So this, okay, we need to basically simply integrate dE, and integration of that simply be dQ. Now considering the fact that k, r, small r are constants, okay, we will take them out. Another r. So we will take all of this out. So what you get? Simply get uh, r square plus r square raised to 3 by 2 integration of dq, integration of dq, and the integration of this small element. Okay, see, this is a uniformly charged ring, so the entire charge on this ring is a capital Q. It's a capital Q. Okay, so integration, that means simply the summation of all the points of dq. So taking a dq here and you keep adding dq, that is the meaning of integration. Suppose still confused. dq, dq, dq. So what basically will end up getting? You get q, capital Q. Basically, it is the entire amount of charge dq. Okay, so integration of dq will simply be equal to q. Simply be equal to q. So this is the electric field intensity. This is the electric field intensity, okay, at the x-axis. The x-axis. Okay. So electric field intensity due to a uniformly charged string is equal to k into small r, okay, upon r square plus small r square into q. Okay. Now let's look at the next topic. Okay. Next derivation. Sorry. Next topic. Let's look at the next topic. Now, electric field intensity due to an infinite line of, sorry, finite line of charge. And if you look, pay attention at this, you will understand a lot of concepts together. Okay, let's look at this electric field intensity due to a finite line of charge. Okay, say this is all positive charges. We take positive charges. It's a good thing to take positive charges. And take a, let's say, point P, where there is some certain test charge which won't be a part of an equation anyway, because it is independent of that. Now look at this. This finite line of charge, this finite line of charge is going to make an angle with this point P. That angle, okay, it is going to be, since there's no space, I'm going to look at this like this, it is alpha. Okay, I hope you're understanding this part, not writing it here. It's alpha. Okay, similarly, this is going to make another small amount of angle, that will be simply beta. Okay, now we have to find the electric field intensity due to the small finite line of charge on this point P. Now look here, when you're considering a line of charge, simply take an element which is at x distance from the center of the line. Okay, do it for all the type of line charges, any type of line system or any system of charges which is in the linear form. So let's say that there is a small amount of, see this red line. Let's consider this to be x. Okay, let's consider this to be x. I hope that you can see that it's x. Okay, this is x, and at at this distance x, let's take a small element. Okay, which is dq, a small amount of charge. Okay, and, and this small amount of charge, which is it's in a small amount of distance from x, we'll take it as dx. We'll take it as dx. Okay, and let's consider the distance between these 2 points as smaller. Sorry, d. Let's consider it to be d. Okay, so what will be the electric field intensity at point P due to the small amount of charge dx? Okay, this dx is going to make an angle theta. It's going to get ugly. So please pay attention. It's not easy. This way. It's going to make a certain angle d theta. It's going to make certain angle d theta. This is d theta. Okay, certain angle d theta. Now let's write the equations. If you have any doubt, please let me know. Okay, if you have any doubt, please let me know. Let's write the equation that is simply electric field intensity is equal to K dq upon r square. Okay. Now, what is r? What is this r? It is the distance between these two charges, these 2 points, and considering the fact that from the center of this charge, distance of t is at a, is equal to d. The length is equal to d, and a small amount of length which I have taken x over here. So it is simply going to become the hypotenuse. This will be the distance between this charge and this charge, which will be simply root of d square plus small r square. Okay, sorry, d square plus x square. Okay, d square plus x square. I hope you're understanding. This is d, this is x. Distance between these two charges will be the hypotenuse. It will be d square plus x square, root of d square plus x square. And so we will substitute that over here in this place, r square. So we'll remove that r. And in that place, we'll simply write d square plus x square. Okay, great till now. It's a good thing. Okay, so right now what we have done is simply found out the electric field intensity at what point? We have found it at simply this point. Okay, this is going to be d. But we are not interested in that. We are interested at this point. Okay, along the x-axis. That is DE, making a certain angle theta. Okay, making a certain angle theta. Guys, remember that this beta over here is actually the angle between this. Okay, just rub it off. Right, beta over here. Okay. So, what will be dE cos theta? Simply be equal to dE cos theta equal to K dq upon d square plus x square cos theta. Okay, it will be this. Now, what we'll do is look at this equation. What do you see? What is something which is abnormal? Not abnormal, but very difficult in terms of solving. The thing is, this equation has two variables. Theta is one variable. Theta is a variable because you can keep increasing theta, decreasing theta. Similarly, you've taken a distance of x where there is a small amount of charge dq. So you can increase and decrease the distance x. So even that is variable. What is constant is d. D is constant, k is constant. Okay. So we need to bring this into one variable. Either you bring it in terms of x, either you bring it in terms of theta. Okay. So let's see what we can do. Now I'll rub it off. I hope you have written it. I hope you have written it. Okay, I'm rubbing it off.
Sir, why we are not taking the y component of electric field?
Now I'll tell you why. See, if suppose y component, okay, the y component will be along y axis, along this side. Considering this, okay, it's going top, 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 top. There will be a y component this side, and due to a charge over here, somewhere over here, y component will be this side. They will cancel each other, no? One will be towards negative y-axis, one will be towards positive y-axis. They're going to cancel each other. So we are not considering that. What is not going to cancel each other? That is the x component. So x component is going to be added. I hope you got that clear. Is that clear? Is that clear? See.
Yes, sir. Yes, sir.
Yeah. So there is for those who don't know, y-axis, there is a charge somewhere around here. Okay, there is a charge somewhere around here at the negative y-axis, which is going to produce a component like this, which is going to go towards the positive axis. There is another component here which is going towards the negative axis. These two will cancel each other. What doesn't cancel is this. They add. Okay, that's as easy as it is. Okay, so now I hope you have written the previous equation which I have rubbed off. Look now, in that dq can be written as what? Let's consider lambda. What is lambda? Charge density. What it simply is? It's charge per unit length. Charge per unit area in terms of if you take an area, a system of charges in an area. So lambda is equal to
Good morning, sir.
Yeah.
Good morning, sir.
Good morning, ma'am. Good morning, ma'am.
Children, I wanted to talk to you. Today is the first lecture of sir. There will be offline video also. Timing is, I think you have got it, which I have uploaded. You got it or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
From today onwards, you will be maintaining the notebook. You know that notebook is also there. Okay, marks is also, you get marks on the notebooks. So maintenance of the notebook you have to do. You can purchase your book from Sagar Bookstore on Monday and Friday. Okay? Hearing?
Yes, ma'am.
Yeah. And your attendance from today will be marked. So remember, in all the classes, your attendance is mandatory because this will go in the board. Because board has already given that online lectures also we have to take care of the attendance of the students, and that we have to send. So make sure 12th and 10th you have to be very particular during the online lectures. Is it clear?
Yes, ma'am.
Clear? Sir, you can continue.
Yes, ma'am. Okay. So charge density lambda is equal to Q by L. You take L over here. Okay, so I'll drop this L off, and this will become L lambda Q equal to Q. So differentiation of dq will, I'll just write that properly. Differentiation of dq, okay, will be equal to lambda into dl. Now, what is dl? dl is what is dq? Small amount of charge. At what point? The distance of dx. So dl will be dx. Okay. So now we will substitute dq as lambda dx. Okay, we'll substitute dq as lambda dx, and so we will simply write dE cos theta equals to, okay, k lambda a, that is dq over here, lambda dx, okay, cos theta upon p square plus x square. D square plus x square. Now, you see, it's still in two terms, x and theta and x. So we'll turn it into terms of theta. Look at this small angle theta. What is tan theta? Tan theta is opposite by adjacent. What is opposite? X. What is adjacent? D. So tan theta is equal to x by d. Let's write it here. Tan theta is equal to x by d. And so x is equal to, take d there, what you'll get? X is equal to d tan theta. Okay, x is equal to, it's not, cannot see. X is equal to d tan theta. And so, what will be the differentiation of this? The differentiation of this will be, okay, dx equals to d into sec square theta, okay, sec square theta, d theta, okay, d sec square theta, d theta. So instead of writing dx over here, we will write d sec square theta, d theta. And so we will substitute that small amount of dx. Okay. What we'll get? You get dx, sorry, d sec square theta, okay, d theta, okay, and there was a, sorry, cos theta also. So cos theta, d theta, okay. So now we can integrate this. Why we can integrate this? Because now it becomes easy. It becomes easy. We will write x also in terms of. So I told you x is equal to tan d into tan theta. So x square will be d square tan square theta. Okay, x square will be equal to d square tan d square into tan square theta. You take d square common.